We have a change with respect to the printed program, so the second talk will be given by George Manias. But now we'll start with Simon Harrer, who is co-founder and CEO of Entropy Data, which was founded more or less exactly 1 year ago. Last week they celebrated their first anniversary, and he is here to report about his current work. So Simon, the stage is yours.
Thank you. Okay, good morning from my side. My name is Simon. I'm a software engineer at heart, and I'm a builder. And I happen to do a PhD at some point in Bamberg, but actually I'm a builder. I like to build things. And that's a great moment to be in this world right now, because if you're a builder and you have a vision and you want to do something, you can use AI to quickly build these things. And that's what makes it a moment, a very, very interesting time for me. I switched to the world of data about 4 or 5 years ago, and being in the services, operational software world before. And my mission is kind of transporting my knowledge, my experience from building software, from building services, from designing them, from architecting them, into the world of data. And I did a few things. We created a website around data mesh with a lot of content. It's about typically ranked 1 or 2 on Google. If you still use Google, probably not, but when you think back, that was a thing. Then we have some other tools in the open source world, some other websites, and this will be probably part of the core of the talk. I'm a member in the standardization committees at the Linux Foundation on standards in the data world, on metadata standards. So that will be part of the core of my talk. My day job, I'm now the CEO and co-founder of our startup. We are 6 people. We have use a lot of tokens, obviously. We don't write code by hand anymore. But we have customers worldwide, from the US to Australia, mostly Europe, and we will reach 1 million revenue per year this year, and it looks very good. Yeah, just to and maybe that's interesting. So again, I'm a builder. I like to build things, and I like to connect and talk to people, but I don't like writing papers, and I don't like doing the evaluation. So that's why I always try to find partners to do that with me. And I did find someone from King's College, and Harrer, who's also here from HTW Berlin, where we published a paper here on automating data governance with GenAI. This is the paper that was accepted at SummerSOC here, again with people from King's College and Eindhoven and Tilburg University. And we also got another paper accepted at ACWS with the help of Stuttgart University. That's kind of my approach to this. So I try to build things, provide the context, and then take the power of university for the evaluation. Okay, but let's start. I want to kick off the talk with a peek into the future. Quickly coming to that. Then we will learn a lot about standards, the ones that I'm involved with. I can share a little bit on that. And then we have to revisit the future, because, as you know, the future takes time, because the LLMs are so slow. So let's peek into the future. What if we already had these open standards for data products? What if they were already there? What can we do with them? What do they enable us? What do they empower? And let's have a look. Conceptually, what I'm shown quickly will be, I'll basically encode the service, we call it a data product in the data world, and I encode the API, we call it a data contract, in YAML formats, and just feed it into the agent. The agent is using skills, which encoded how to build the service, the data product, and we combine it with tools. In the skills it says which tools to use, and then we have to connect the tools and authenticate. And in combination we get the service fully automatically. It's driven by this, and by this, and then the agent in the middle combines them and implements, builds the actual product that we want to have. Think it like an API first approach. We call the contract first, but again, I'm translating things from the services world into this data world. And I want to quickly show you, and I have to, okay. So, here I have a folder with just 2 files, the other scripts we can ignore. So I have the contract file, that's the API file, describing how my table that I want to have, that's not yet there, just describe what my table should look like, what data should it contain. And then this ODPS, the product YAML, that's just describing the box. Like from an architectural point of view, it's just a box, and that's the API. That's the data. And that's the box that produces that data in very, very simple terms. When we visualize this, the box looks like this. There's not a lot of information in that YAML file, it's really just this box. The key part is in the contract. And maybe enlarge it a little bit. So this is basically, this is what we want to have. It does not yet exist, but we want to have a clearance recommendations table on some database technology where we have some fields, some IDs like stock keeping unit to identify the articles when they were last sold, the current list price, the effective price, and so on and so forth. The idea is to detect the articles that we need to sell quickly. So the kind of the things that were on the shelf too long, but in an evaluation, so where do we have to put the effort in selling them quickly? Where do we have to start marketing campaigns and so on? In the contract there's much more, but that's the essence here. And the contract is anchored in an ontology. So I'm linking here to a stock keeping unit. Maybe it's just, this is better to visualize. Moment. I think of it like an RDF graph or something, like an ontology. So the contract is anchored into the ontology, into the business data model. So we already defined what a stock keeping unit is, and in the contract we basically say this column, that's actually a stock keeping unit defined in our ontology. And this is what we do up front. And then we combine it with a skill repository. That means we basically have a Git repository that encodes how we build these services, these data products. That's the knowledge in. How do we build this for, in this case, Snowflake? How do we use the technology? What are the company guidelines, rules, policies that we use? It's basically just a Git repository with text files, markdown files. But all the coding agents support this through plugins. So in any coding agents you can plug in such a a skill repository as a plugin, and it will automatically use that. And third, we integrated it with tools that the AI can use. But I show them later. Let's just start. Let's just enter our Claude and basically just tell it, please implement it. Don't ask me anything. If you need access to other data sources, please just request it. if you have the permission, approve it yourself, if you can, and do not ask any follow-up questions, just do it. And, well, let's start it. We will not watch it the whole time because it takes about between 15 and 25 minutes, and it doesn't make sense for 30 people to watch Claude work. So in the meantime, we will learn a little bit about standards, but we will revisit it later. And the idea is that at the end, that box is implemented, it's fully working, it will use 3 other data products, it will have requested access, and we will have a look, fingers crossed, later.
Simon,
yeah.
Is this repeatable? If you would start in parallel the same one or later on the same one, would you get the same result?
Well, it's.
We can take the question offline. Yeah.
I think it's repeatable enough. Maybe one thing I demoed it like I don't know 10 times, and it always worked. I did not have a close look and compare the results, to be honest. I think there might be some variation,
okay.
But where it's baked into which data products to use, it was always the same ones it identified to use. I didn't compare the internal pipeline logic it generated. That would have been very interesting. Sadly, I do not have the data anymore, but that would be very interesting, to be honest. Yeah. Okay. So we will revisit that later, just to keep your attention, so you stay for the end.
Yeah.
Okay. Now the actual core of the talk: open standards for data products. And maybe not everybody here is familiar completely with data products. That idea basically is a little older than data mesh, but with data mesh it really got its recognition. And the idea is we don't just share data in our company, we share data as a product. We apply product thinking on sharing data on. So we have an owner who's really responsible for that data set that we share. We optimize it so our consumers can work with the data in a good way. And we think of quality. And what Data Mesh also did was we also included the factory in, the supply chain, the code. It's not just the data sitting there, it's also how the data was produced that was also considered critical. And so we will focus here on that. Now the building blocks is, think of when you're from the services world as like the services, but in the data world. And it's a little different, not because the interface is data. It's just think of it like always a read-only interface. And there's no behavior. The behavior is in the pipeline itself, but the interface itself has no behavior offered. Just an observability read-only interface. To me, this is a birth certificate of a data product. Now, typically, when you design a data product or even design a service, probably very similar, right? We go out, we talk to people, we start with a conversation, we fill in such a canvas, probably starting from the use case side, which you should do, and then you define the interface, you define where you which other systems you need to connect, and then you implement the thing in the middle. That's kind of the birth certificate. And now when we look at that component that we create, it's basically an architectural box. And we have our APIs, our output ports, our interfaces to share it further on. And then we build upon other things through the input ports. And we have a lot of these things that we also know from the software engineering world, like CI/CD pipelines. We need to implement observability in the pipelines. Test is also relevant. Cost is actually quite important because in the data world, storage is basically free now. And the only thing that's expensive is compute, so when the pipeline is running. And if you process a lot of data, you need a lot of compute. And I think it's at BigQuery, you pay like $10 per gigabyte scanned. And if you do that scan every 10 minutes, well, it can really accumulate a lot. So cost management has become really a huge issue here. Here's the transformation code, the SQL pipeline, so to say, that transforms that data into another form of data and combines them and builds these aggregations. But that's kind of the building block of a data product. And for people, I think from the services world, it feels quite, natural. Yes, please?
Simon, what is the testing there?
Mm-hmm.
Who's doing testing?
Yeah.
So if it is a product,
Yeah.
this is not human.
Yeah. Yeah, so you can do testing in between for the pipeline, because you have logic in there, the transformation mapping logic, you can test that, so there's even the concept of unit tests now. But you can also test, especially here, and we will see that later on, test characteristics of the data you share on. Think of it like you have a column, and you can test that there are at most 1% null values in that column. So you think in columns, or you think in the whole data set, and you think of characteristics. Because in the end, if you want to process it further, use it further, it makes a huge difference if there are only at most 1% null values guaranteed, and you test it and you rely on that. For machine learning, because in machine learning we don't care if there's just 1% null values, we can still work with the data. If it's just empty, completely empty and completely null, it's a completely different story. So that's why these things are necessary. Okay, there were data products, very short introduction. The other thing are open standards, and probably you know more about open standards than me, but just a short intro, why do we need those? And well, in these cases I always resort to XKCD, because I think they have the best approach to motivate for these standards. And I think the one is this, which is obviously what's the best format for encoding the day. It's obviously the ISO standard, and all other things are wrong. The other thing is also how to count. There's only one way to count, it's 3, 2, 1, go. The others are, of course, skewed, and if you have seen Lethal Weapon, and there's always this discussion on how to count, and they don't really agree, and it's always complicated. So if they would have used that standard, maybe they would have been much more successful in these movies. And obviously the problem, however, with these standards is that, well, whenever you have some standards and some other people come along, you create another standard to solve the issues of the other standards, but actually you don't solve anything. You just have more standards now. So it's a complicated thing. Now we always try to achieve great things and simplify life, but then life comes in the way and makes it hard. I want to focus on open standards. So open standards are, for me, are things that are really established, really used, de facto standards based on adoption. They are owned by initiatives, by like institutes, not by a single vendor. They are not controlled, even in these institutes, by a single vendor, but by many different parties. So we have all these insights, and they are open. We don't have to pay just to read that standard. That's kind of my definition. And well, when we combine them now, and have a look at what open standards exist in the data products world, and we can look at the birth certificate, and we can quickly see and have some ideas where we could standardize. We could standardize here at the interface. We can standardize here at the transmission. We can standardize here in the building block. And the same thing if you look at that image, the component, there are several standardization possibilities, of course. 2 months ago, I think, we created that data landscape. So we, from our perspective, we captured all the open standards that we knew were in the data world, and categorized them and created an opinionated map. And it was funny because some people at ThoughtWorks, Tian Kai Fen, he just wrote me quickly afterwards, this is exactly what I need for my client. This really filled a gap. So people really want to know which open standards there are, what do they do, and how can I use them. And we categorize them in these 4 categories: adopt, situational, assess, and caution. We can quickly have a look here. Here are standards for how data is described, where the data is living, with all the new standards like Iceberg, and also older one like S3. We have data standards how data flows between the systems. Well, SFTP is still there, of course. And how data is processed and reshaped. And SQL is still there. And then how it's found and traced and queried, observed, and governed. I will not touch all the standards. It doesn't make sense to do that. I will only touch the standards where I'm actively involved, because this is where I can share a little bit of, well, not gossip, but insights, and that might be interesting. So let's start with standards for data contracts. And again, think like, this is like an API spec, but for data, and just for read only. And the idea is, we typically, it's always the case, we have always a producer that provides data, and we have a consumer that wants to access and use that data. And the idea is the contract provides that layer of trust towards the consumer and is owned by the producer. And so the data contract specifies guarantees on that data. This is how we define that. And these guarantees, there could be, of course, who owns it, how to contact them perhaps, what's the structure of the data, what's its meaning, its semantics, what's its quality. We touched a little bit with the 1% null values at most. But also terms of use. What are you allowed to do with the data and what you're not allowed to do with the data? We in Europe, we have the GDPR, and other countries also have it as well, because we are very good at exporting regulations. That's the strength of the EU. So this is really a thing. And when you violate these terms of use, that if you violate internally the GDPR and use the data for something that is not allowed, legally it's like a data breach with all the consequences. So it's really problematic. So that's kind of the conceptual behind a data contract. And when you think of where's the data contract located, it's right here. So here we can protect these output ports and specify them with a data contract. And of course on the left-hand side as well. We call them consumer-driven data contracts, but we don't touch that. But it's essentially, I can also protect the things that I'm relying on. And I could put that in there as well. And how did it start? Well, actually, once upon a time, every company, realized the need for such things. And so everybody built their own format. And then it's some time later, we also created our own format, but also PayPal, the payment transaction company, they also created their own format, and they open sourced it and donated it to the Linux Foundation. And I joined, but the problem was that the donated version was very paper specific. And if you were not PayPal, it was hard to use. And so I joined the technical steering committee back then, and we converted or improved it so other companies can use it. And that was, last year we released the version 3, and since then it's really usable by everybody. So it originates from PayPal, but it's now very well accepted. It has, I think at the moment it has 1,000 GitHub stars, and a lot of vendors have now also jumped on the bandwagon. I know personally from many companies that use it. the problem is that these companies haven't written about it, so I can't disclose that. But it's very interesting. So it has made a huge jump in adoption. Yes, please.
Just a question: when you talk about usability, so that only PayPal could use it, and wherein lies this usability issue then?
But they had BigQuery as the database technology from Google, and everything was optimized for BigQuery. And if you would have used Databricks or Snowflake or Postgres or whatever, this would have not worked. So that's the main part. There were some other parts which were linked to internal systems of PayPal, and only PayPal had these internal systems, and so these fields didn't make sense, and we wanted to clean and sensible standard. Yeah. Okay, I'll quickly go through the parts here. It's a YAML format. It obviously has an ID, a name, a version, and some status. The idea is just like APIs. You can version them, you can phase them in, you can deprecate them, you can phase them out. I think interesting here is the schema. So that the schema basically encodes the structure of the tables that we offer. Can be one or many tables, and then we have the fields. And in these fields, we encode the physical type, the type maybe in the SQL, but also logical type. So different levels. We also encode things like data classification or confidentiality levels, privacy levels. We encode what does it actually mean. Maybe you have customer underscore ID, and it's the business name here is it's not that interesting, but here's a customer identifier, so something more readable. And we can put more descriptions describing it and linking it to the semantic world as well, that I showed in the very beginning, linking it to an ontology. Data quality is encoded here. So here we're using a quality check from a library which says we don't want any invalid values, and only these three are valid values for our order status. But there are different other libraries, and typically it's never this one like absolute, but only relative with percentages. And you can also define quality checks just with SQL. And we add the information who's responsible and how to contact them, because people might have questions around the data that they are offered. We encode the terms of use. Here, what's the purpose, how the typical usage, limitations, and also linking to other policies. So license agreements, especially if you buy data from the outside, like weather data, statistics data, there's always a license attached to that. You're not allowed to do anything with it. You obviously can't sell it outside. You can just make it public. Just one minor thing, but there are some other restrictions as well if you read these. And so you have to make sure to link them so people that use the data can then know, okay, I have to consider that. I have to take that into account and have to check that if it's really feasible to use that in my use case. We have service level agreements, availability, retention, freshness, just an example. Thing is, availability no one is using it. I have it in there, but in the data world, availability is never actually used as a SLA. Doesn't matter because data is just sitting there, and so if it just sits on S3, you would have to put in the availability of S3. Doesn't have anything to do with how you produce the data. You would just use it as the availability metric of the underlying service that just provides read access to the data. Much more interesting is freshness or latency. When you order something in the online shop, you click buy. How long does it take that it's reflected in the data I can observe on these files in S3? On these JSON files, for instance. That's an important SLA. And then last week we have also where the actual data is. Here it's just Postgres, but could be anywhere. So that's the standard, and we now created maybe that YAML manually. Now what? Now we have a YAML file. Doesn't help us first. And the idea is, of course, to automate. Because it has so good metadata, we can automate so many things with it. Of course, we can do code generation. That's why when you think of OpenAPI, this is where OpenAPI becomes successful, because we had these all great code generators for both the server and the client side. Here we can also do that, but the interesting thing is actually here. We can test this. We can, because we have no logic in the data. We have characteristics in the data, and what did we do in the contract? We described characteristics. So what you can do is use the contract, connect with the data, and check if the characteristics are met in the data. And if they're not met, we can say, we can raise an alert, we can inform people to fix, or they know that they are affected by that the characteristic is no longer in the data. And for that we created open source tooling. So we created this open source tool that can effectively read that contract, connect to these data sources, and do these characteristic checks. And we know that a lot of people are using that, and a lot of companies as well. This is really very popular, and we know that because they also contribute back to the CLI, or they ask questions. But it's really used a lot. And when you compare the GitHub stars over time, you see that the standard here in blue and the tooling here in red, I think they help each other. And if you want to have an open standard that's successful, you need open source tooling, because then people will actually use it, because they have a benefit, not just the YAML format, because just having a YAML format file doesn't help you anything, doesn't bring you value. But if you have the automation around it, the testing, or generating a nice HTML view as well from it, or all these things, then it works quite well. We also created an open source editor to edit that very easily. But actually, companies have demanded that they need Excel. There was a funny movement. Excel is not dead yet. We didn't want to provide it, but they really wanted that. And so I think open standards in that word really need the format, but also the tooling around it, so that they will get adoption. And we're seeing that getting huge adoption, and yeah, will be very interesting to watch in the near future. So we revisit, so we see in standards here for these elements on the outside. Let's go for the data products, for the box, so to say, for this box in between. And there's a compatible standard that basically says, well, we consider that this box is described by this standard, and we point for these input and output ports to the other standard files. And it fits quite naturally. I've just shown it on the right-hand side. But essentially, well, it's just a very fitting, matching standard. Then when you think of that, and when you have these building blocks, then you can compute that graph. Now we have maybe an application that has an output port, then you have a data product that links to that via an input port, and then again, and so on. And that's basically how you then can draw the whole data mesh with all the data products. And conceptually, for me, everything is a box, whether we call it application or data product, and they all have input and output ports. To me, that feels natural as an architect. And that's very helpful to encode that. I don't want to go into more detail, but just we typically don't encode too much of the internals in here. It's just the outside view. You can also add internals if you want, but typically it suffices if you just have there's a black box view. And the last one is semantics. This is where we are, as a company, we are part of that initiative that has been now donated also to the, in this case, to the Apache Software Foundation. And yeah, well, they have a little bit of a problem with naming. Because they started off by calling them the OSI initiative. And when you, I think when you remember something some years ago in your studies, you maybe have touched some other standards which also used the OSI acronym, and they were quite famous, to be honest. So that was already very funny that they did this. And now with the donation to the Apache Software Foundation, they have renamed themselves to Apache Aussie, which is, if you're in the German-speaking world, is also not the best choice of words. Although that's why I added the kangaroo. That makes the context clear, and that helps to some extent. So they're not very good in naming, but naming is hard. We all know that. The idea here was that, well, now we have agents. Not only humans, we also have agents now, and we need to support these agents. And agents need semantic. And that's kind of where it originated. Snowflake was the driver behind that. And basically they said, no, we need these semantic models where we define data tables and how they relate, and also metrics that are computed. And typically they were used by BI tools for reporting, but now we have agents they also want to use that. And it's very interesting if you have the metrics in there and the agents can use it, and they can use to compute and answer questions from the consumers. And so that's how the standard came into being. And what's interesting here is that they added this AI context block basically to every element, and so you can add instructions just for the AI, or synonyms or example queries and much more to help AI understand what the data means. That was actually new. When you think of the data set and the relationships, that's very similar like to the data contract. And metrics was also new, where you define fields that do not exist in the actual table. Think of like a full name that is computed by first name plus space plus last name. But the full name table did not exist, was not materialized, but you still define that's how you would compute that. Or what is the order of the total revenue, that metric. And you just define the logic, the formula. But if you say, I want to filter just for orders from Germany, you can still compute the metric, because you will not pre-compute the metric for all the slices and dices with the data. So that's why you need to provide the formula separately. And when we compare them, well, actually, we had some innovation here with the metrics and dynamic fields and the AI context, and the other standard is now following up. So eventually, they will, from that point of view, they will merge. But the contract is much more. Again, it has its terms of use and the quality and SLA aspects. So at some point, there will be almost a bidirectional mapping, except of the terms of use and the quality. There are other parts of that, and I just want to point out one, the ontologies. This is where we basically reinvent ontologies, but we now encode them in YAMLs instead of RDF. Because RDF is so, what do you say, 2010? I don't know. The RDF was very big in the semantic web world some time ago. A lot of people invested a lot of energy in creating that. But with agents, I don't know, it has to be reinvented. And this is now just encoded in YAML. Because maybe it's just RDF and it's very hard to read. But the idea is actually quite nice. So you define your ontology here. And you then point from these contracts, from the interfaces here, to elements in your ontology. And then based on that, you know, oh, I can combine this and that through a join via this custom ID. That's kind of the core idea. I know then I can combine this data product, this data offering, because I anchored them in my ontology. So that was a short overview of these three standards here, and here that I'm attached to. But there are many more standards out there, also competing standards. But I think these in combination, they're very powerful. Because I can describe the box, I can describe the interfaces, and I can link them in the ontology. And let's check where the future is now. It looks like it's finished. That's good. It did a lot of things. That's also good. That's okay. So it's now implemented. It's now fully done. Let me double check how long it took. Didn't check that. 20 minutes. Can we check the usage? Oh, it's okay. A few dollars. It's fine.
So how many tokens?
Yeah, I don't see it. Normally it's there if it's a lot. I maybe check again the usage. Oh, here we see
50,000.
Here we see it used Opus 4.8 and Haiku 4.5, and a lot of cache writes and reads. I would say the key, that what's expensive are the output tokens, because output tokens are always 10 times more expensive than input, and we have 80,000 here. I think that's the key driver for the $7 here that we used. I have some tools in the background that optimize it as well. So it's not a fair number because there are tools that intercept the call from the LLM to my command line, and then it will do things to save tokens. So take these numbers with care. But what happened actually is that this box now, let's enlarge that, that's now implemented. And it automatically determined, based on that interface that we described, and we didn't provide it much more, we just said, this is a box and it has that name and this is the interface. It will automatically found in our registry, okay, these other data products, and there are much more, are available. It evaluated them. Then it decided, I need access to these three. I requested access, used that, did that, and then it built the pipeline for that box. That is basically, the building is now fully automated. And we can now go in and review that, of course. We can also add a new field here and try to start it again, and then it will update that pipeline, and maybe it can fulfill that new field from these three. Then we don't need any additional dependency. Or it would add another dependency to join that, or it says it's not possible based on the actual data. Please help me. And I think that's the power of these metadata and these standards, and because of the semantics, it could detect, because all these semantics pointed to the same elements, and it could detect which elements are fit to combine that. And so that's, yeah. What we also have is, that's also another standard here, it's open lineage. So it basically shows us a few deeper, where we say, okay, we create this table and we use these other tables in SQL. In this case, we just had one internal step. Could be, like, conceptually could also be more, and could also have internal intermediate tables if the pipeline would be much more complex. Yeah, you could also do that, and we would see that as well. also based on open standards. Okay, maybe let's have a look at the SQL pipeline that was generated. That's also interesting. Yeah, here. So these 123 lines of SQL code basically were generated, and it already used best practices, how you build that, where you, for each incoming data, you created this common table, it created this common table expression, where it just selected the fields that it needs. First a projection of them for these three tables, then they joined them, we applied some scoring, and then other scoring, and then we created the final table. But it looks very clean. Whether it's actually, I didn't really check it that it did the right thing, to be honest. This I did not do, and this of course has to be done by the owner of the data product, of course. But it's really driven, and that this is really, and you have these standards, when you have these formats, you can really go like spec-driven development, so to say. And yeah, that's very nice. Okay. That was the future. So coming to an end now, if you only remember one thing from today, it's agents make building very, very cheap. But the description of the data is now the bottleneck. This is where the humans are still necessary. We have to describe these contracts. We have to say what we want. What should it be? We have to anchor that in this ontology. We have to define the ontology. We can use AI as an assistant, but this is where we have to make the decision still. And it's nice because it still leaves us a place to be. And open standards can really help with open tooling. And they also support this or prevent the vendor lock-in, and that's crucial, because when you look at all the big companies, what are they doing now? When you look at Databricks, Snowflake, Google, Microsoft, who can name everybody, they pull all the metadata into their fence. This is what they all do. And the open standards are kind of the counter movement. We want to get them free. We want to show you have to make sure you own them, because they are so powerful. They're so important for their use. And that's kind of my impulse for today. Thank you.
So, thank you, Simon. I assume there are questions in the panel.
Thanks for sharing this, and I really like sort of this specification-based building, and I think we also have projects, and I think Bernhard had this question, is it sort of producing the same code? And I think we discussed this and we said it's the wrong question, but also this perhaps for the break, because who cares? But so 26 is the last year we looked at code, and I think so there's still probably some time to look at code this year. But my question goes the role of sort of the developer. So our experience, not on the data side, but on the architecture side, is that basically experienced humans are much better in sort of getting the specification than if we ask Claude or whoever to do the specification according to best practice. And you said also the humans are pretty good at the data. But where do you think, why is this? Why are we, because obviously sort of once you show the data stuff, it looks pretty much as sort of, oh yeah, that's the obvious way to do it. And we had this similar for building architectures. Once the human has built it, it looks like, and then also when you then put what the human built into an LLM, the LLM says, oh yeah, that's how you build it, but we never got it sort of to it. What do you think is sort of the, why can we not automate that part so well? And it seems like it's not just the architecture, it's also your experience, it's the data as well.
Yeah, great question. I think it's because humans talk to other humans, and because of that we are able to get feedback in, like for these specifications, No, and we have also additional knowledge that is not yet explicit. But I think if the AI would be able to talk to other humans, and if AI would be able to have that knowledge that is yet at the moment implicit in our minds, it would be very tough. But there are some hurdles for that. I think that's essentially it. If you make, because the theory is, if you make all the knowledge explicit, then AI will be able to handle that. And it's not, at the moment it's not able to do that, but in general it could. It could ask, we could give it access to our Teams or Slack or WhatsApp, and then it just ask the humans to get their knowledge out. Conceptually it would be possible.
But would you need to, because obviously what those humans know, that's also in another. So you'd be trying to basically having agents talking to other networks,
Yeah.
especially in HCI, because usually they're focused which goes a bit out. So the question is, I
Yeah.
respond with
Yeah.
Can you repeat the question because we don't hear it?
It's when you do work with humans, like in a focus group on human-computer interaction, and you compare it to the results what agents were able to do, it's quite close. I work in enterprises, and a lot of that knowledge in enterprises is not explicit. And that's why a lot of humans are still necessary, because that is so implicit in the brains. But everybody who I talk to some VC people, and their strategies is only invest in strategies to make that knowledge explicit, which is a little sad, because then the goal is to replace the humans. But that's more of an ethics topic now and less a data topic now.
Yeah, short question. Before you showed in this semantic standard that there is now a new section specifically for AI, right? And it had things like examples, synonyms, etc. And when I looked at this, I was like, well, this looks also quite helpful for humans. I'm wondering, is there really any difference in things that an AI needs to understand stuff different from what humans need to understand stuff?
Yeah. From my experience, if you optimize for agents, you typically also optimize for humans.
But also the other way around?
The other way around is not the case, because if you optimize for humans, they might have other coping mechanisms, which is totally fine, and they're used to that, because if it's not described well enough, they just have a way of contact, a phone number, they can just phone, and maybe that's even the economically easier way, because just provide that way of contact and provide a way so humans can interact very quickly with each other. But the agent doesn't do that. The agent needs everything explicit. But if it's explicit, humans can also benefit from that.
Yeah,
I think that's yeah.
Thanks.
Thank you. So I find the open data contract really interesting. Is there open data that adheres to this contract available openly, or is it all locked away in companies?
Yeah, very, very, very good. It's mostly used within the companies, to be honest. Yesterday evening I started an army of agents to search for usages of that open data contract. It was like 140 agents that were spinned off, and then they went away, and they found one Git repository of a French company, a French non-profit, that had open data around weather, and they had 1 terabyte of data, and they used like 43 data contracts for that, very actively. So that's the only thing I can really cite, but I think that will increase. But it came from the need within companies to share that within companies, and the open data world is somewhat disconnected. There's a wall between different technologies, different ways of doing things. So it has not yet swapped over. How do you say? It's yeah.
But that's going to make it tricky for research to explore this, right? If you only have a contract but no data to play with.
Yeah. But again, these 43 contracts are now out there. You can now start research and check if this is well used. I don't know.
You are saying agents are cheap, but data products are expensive. What about if the agents become more expensive? Or in other words, what about digital sovereignty? Are you using apparently only US products? What about Mistral? Where is the data sitting? In Europe or somewhere else? What do your customers say about it?
What I showed is it's a very important aspect. What I've shown is there's no limit to, you have to do that with US companies. So everything I showed, there's an open alternative, so you can do all of that on-premise in your own system. The only thing is you need an LLM somehow. You need a tool that acts as a coding agent that can, but there's so many open standards in between, so I don't see any problem. You can just do it on-prem. I just do it with US providers because they provide me with basically almost subsidized and free tokens at the moment. And from an economical point of view, as a startup, that makes very much sense. And but when you look at all the open source models like GLM 5.2, which was just released, or Google Gamma, they're very advanced. So I could try basically with Google Gamma, probably. I'm not totally sure but if it's really that good yet, but I would assume that it's possible to do that on that machine nowadays in some way. So I don't see any problem. The only problem that comes down to is the chips and the energy, if you do that at scale. But again, I'm just using it to building data products. The actual running is then again in the classical deterministic world. So it makes it a little bit nice. It's not, you don't have these agents running in that what I've shown. Now what you still would need, and that's maybe interesting to see, when you remember where we started off, we have the skill repository that encodes how we build that, and then we build it, but we are missing this feedback loop to improve that here based on what happened here, and maybe also keep that in line with our policies, that what we do want to do in our company. So we need other loops here that update that. And in the agent world, it's all about loops now. So you have to think about how do you connect them, how do you update this so it's up to date, it follows the conventions my governance team or my CTO encoded, so that all these skills are right, and so that these skills ensure that these are built in the right way. So then, when you go that route, you will have a lot more agents, not just, this is very hard to do deterministically, so you have a lot of agents, and then it's again the energy and hardware costs.
I had a chance to, I was asked to ask a very short question. I will do my best. First of all, thanks to the talk. It's very much appreciated. It's very inspiring. And in your case, you're focusing on data processing in a way. And that makes total sense. However, when we speak about AI, we also have a lot of those data sets which are used for training, validation, and so on. And this area, which is even less standardized than anything that we have in data processing. Do you think some of your standards or some way of describing semantics can also be applied to those data sets? Because we will be very interested in those, because it's very difficult to get at least some sense of over all the data being collected, and it's just a nightmare to maintain.
Yeah, if it's structured data, I think it works very well. The problem is some training data is just unstructured and you have just a mess. So that's where it's hard. So it's not no magic bullet, it's no fairy dust that basically makes out of that mess a mesh or something. It's just, so if you have structured data, it works. And it really for any structured data. We have also customers who have just CSV files on an SFTP they share. And you can pull a contract on that. Doesn't have to be that huge data break, so big data instance. Just CSV file on SFTP. Or your training data, wherever it sits.
Okay, with that, let's thank Simon again. And then we will have a 15-minute coffee break.
Outside. Der Wolfgang mal zugucken.
Ich sag mal so.